Hello friends, welcome to Abhiyanvi tutorials. So today in this video we'll see verification validation interview in medical domain. So I cracked this interview recently. So I want to share my experience. So in interview it is held for 30 minutes and total 17 questions are asked. So I will share all those questions and we'll discuss one by one. Okay. So first question is, what is the class of medical device you tested? So if you see, there are three classes of medical devices. The class one is risk is low, and if risk is medium, then it is class two, and risk is high, then it is class three. Okay. So I worked on electrosurgical generator, so I said it is class two device where the risk is medium. Okay. And the second question is, do you aware of any invasive, non-invasive category of the product? Is your product is invasive or non-invasive? So here we have to understand what is invasive and non-invasive products. So invasive means the device will be connected to the body through skin cut or device is used inside the body. That is called invasive product. And non-invasive means we won't use that instrument into the body. So it is outside the body. Okay, that is non-invasive. So my product here, electrosurgical generator, is a non-invasive product. Okay, I said it is non-invasive. Then third question is, explain me any of the requirement you tested on your product. Okay, so here I am using electrosurgical generator. So it is having a monopolar port and it is having two modes, cut and coag. So we'll use the monopolar instrument to cut the cancer lesions, or coag means we can seal the cancer lesions. So I said the requirement is like cut mode, the maximum power shall be 150, and for coag mode maximum power should be 200. So that is a requirement I said. So how you test, he asked. Then I said we'll increase the increment button, plus button. You press the plus button so that highest power will be 150. So once it is reached, the test is done and we'll capture the screenshot. And for coag mode also, we'll press the plus increment button so that it will increase up to 200 maximum value and we'll capture the screenshot for our testing. Okay. And fourth one is, he has given an example. So oximeter is nothing but it is used to check the oxygen levels in the blood. Okay. So he said that oximeter is used to measure the oxygen levels of patient greater than or equal to 76 and less than or equal to 97. So that is the level. So he asked me to write the requirement and the test cases and what is the actual and what is the expected results and when you will pass or fail and what is your test strategy. Okay, so I said that a requirement is the oximeter shall measure the oxygen levels from 76 to 97. Okay, so you have to use the word shall. The oximeter shall measure the oxygen levels from 76 to 97. So when I use the from 76 to 97, the 76 and 97 values are included. Okay, so that is the requirement I said. So for testing for test cases, I said three test cases. Verify that lower level of the oxygen level is 76 and verify the higher level of oxygen level is 97, and I can test some 3-4 values in between. Okay, verify the oxygen level is let's say 80 and 90 or 95, like that. Three values you can write the for test cases. Okay, so actual results are what we noted in the testing, and expected will be the values between including 76 greater than or equal to 76 and less than or equal to 97. Okay, so when these values are met, I will pass it, and when these values are out of boundary, out of reach, or if these values are not reaching, then I will make it as fail. Okay, so we asked what is the your test strategy. So I said that I can do the boundary value testing. So for example, lower boundary is 76. So I'll test for the values 76.1 and 75.9. Similarly, for higher levels, 97.1 and 96.9. Okay. So I said that I'll check the boundary values and I'll check the equivalent classes. So one class will be for higher level and one class will be between 76 and 97 and another class is less than 76. So three equivalent classes I will test and according to I will pass and fail the results. Okay. So impressed with that answer. And next question is, if the oxygen level is less than 76 and expected behavior is that instrument shall give the red alarm, will you pass it or fail it? So here he is telling that oxygen level is less than 76, but expected behavior is instrument is giving the red alarm. So in that case, we have to pass the test case. Okay. So I said it is expected behavior, getting the alarm, red alarm is the expected behavior. So we have to pass it, I said. Okay. And the next question is, any test strategy you think to break down this requirement and test it? So I said, right, test strategy is to do the boundary value testing and equivalence class testings for robustness. Okay, you go to the next question. What evidences you gather for your testing? So I said, if instrument is giving the logs, so that is the best approach to capture the evidence because logs will be with the timestamps. So for example, you have to test any timing requirements. So if you use stopwatch or anything, so manual noting time and all, some difference, microseconds or nanoseconds difference will be there. But if you use the logs, that will be the best approach to capture the results. So for timing requirements and also lower level values, higher level values, range of values and all logs are best. And one more thing I said that I will capture the screenshots. Okay. For example, lower level of oximeter is 76, right? So whenever I get the 76 value, I will capture an image and store it. Okay. Similarly, higher level 97, I will capture one image and I save it. So these two things I said, logs and capturing images for evidences. Okay. So next question is SDLC of V model. Explain the respective steps. So I explained the V model. So first we'll do the requirement analysis. Then we'll go for system design. From there we'll go to the architecture design. From there we'll go to the module design. Okay. From there we'll go to the coding. Then we'll go up to unit testing and then system testing. Okay. The unit testing, then integration testing. After that system testing. After that acceptance testing. So I said that all these steps I said, but I also said that in each phase we'll plan for testing also. That is the advantage of V model. So whenever any stage is completed, the same stage we'll plan for testing also, like writing the test cases and all. We plan the testing, but we won't do the testing, but we plan the testing. Okay. For example, requirement analysis is done, then we'll plan the testing for acceptance test. So when you complete the system design, we plan the testing for system testing. Okay. And when you complete the architectural design, we'll plan the testing for integration testing. And when we complete the module testing, then we'll plan testing for unit testing. So like that, we'll do it. Okay. Each phase will plan a testing. So we won't do testing, but we plan the testing. Okay. So this also impressed with my answer. Okay. And next, who does the first step of V model requirement analysis? So I said system engineers will capture the requirements. Okay. So I said system engineer will capture the requirements. He said who will give the requirements. So then I said the client will give the requirements. Okay. So who gathers requirement? Client is system engineers. Okay. And next, tell me any standards you have used for regulatory affairs. So I said I am used a risk management standard, that is ISO, uh, ISO 6, ISO 14971. Okay. And one more standard I set for software development, that is IEC 62304. Okay. These two things I set. Okay. Then interest. Okay. Then second, next question is, have you heard of DHF? So why you need DHF? Okay, so here DHF is nothing but design history file. Okay, so design history file in medical domain is nothing but it is the total documentation of a finished medical device from starting to ending. How design is happened, how testing is done, how certification is done, and all everything. For a finished medical device, it is a total documentation of a medical device, how design, how requirements, everything it will contain. So that is called design history file. Okay. So why you need design history file means to understand the product clearly and get the certification. Okay, and do the testing thoroughly. So it is useful for all those things. So okay, so that is DHF. And what is importance of traceability matrix in entire VNV cycle? Okay. So here traceability matrix, I said it is from requirement to test case to test scripts, from test script to test results. So this is entire traceability that we are using in our company, I said. Okay. So what is the importance means, for example, which requirement is the traceability is matrix is from requirements to test case to test scripts, test script to test results. So what is the importance means, which we will easily know that which requirements are tested by which test case and which test cases are done by which test script. Okay, and where results are stored and are pass fail and all. So I also said that if some test case is failing, then we'll easily go to the test script which is testing the test case, and we'll fix the test script. So like that, traceability is very useful to fill the gaps and fix the issues. Okay, that is the importance of traceability matrix. Then next question is, do you think traceability between system to software along with software to hardware requirements also important, or only knowing software requirements is helpful? He is asking that only software requirements is enough, or you want to know the traceability of system to software also. So I said that all traceabilities are required, and it is always advantageous to have the traceability from system to software also, because if any bug comes in the software, you can go back to system requirements and we'll fill the gap there, and again we'll come to the designing of software, and again we'll modify our test scripts and do the testing. Okay, so it is always advantageous to have the system to software traceability also along with software to hardware traceability. Okay. And next is, which defect management tool you have used? Is it integrated with any test execution tool or requirement management tool? So I said for defect management we are using Jira. So it is not integrated with any test execution tool or requirement management tool. But I said that whenever we are logging a defect, I can give the requirement link or test case link of Polarian into this Jira tool. Okay, that is my answer. And next question is, tell me the various status of defects from starting to end. What status a defect can have? Then I said all stages of defect in the Jira tool. So first is backlog. Okay, then open, then work in progress, then test executed. Okay, then close. Okay, that is, those are the steps I said, and I missed the defer state. So then he reminded me what is the defer state of defect. So I said when we'll defer the defect. For example, software is not completed yet, but we have got a bug. Okay, so in that case, we'll defer the defect to the next build. Okay, so that this process will go continue smoothly. And whenever the software is ready for next build, next milestone, we'll check this bug. Okay, and one more thing I told that if the defect is not disturbing our process or not disturbing the delivery, it's a minor thing which is not affecting our process or delivery, then we can defer the defect to the next build. Okay, guys. So these are the 17 questions asked for me for in the half an hour. Okay. Hope you like this video. If you like this video, subscribe to my channel Abhianvi Tutorials for more such interview questions. Thanks for watching. Bye bye.